Okay, so on number 1, we are looking at a question where they give us a graph and they're asking us all these information for different points on the graph. So we're just going to start off looking at when x equals negative 2. First question asks us f of this number, the function at this number. So we go to negative 2 on our graph, x value negative 2, and where is the dot on our graph? That seems to be down here at negative 2. All right, I'm going to stick with x equals negative 2, so I'm going to go down this chart. Next question, the limit as x approaches our number from the right. So here's negative 2. Here's the right of negative 2. As I approach it from the right, we have still this value of negative 2. All right, next question. The limit as the function approaches our number from the left. Here's negative 2. Here's the function on the left of negative 2. As we approach from the left, we're actually approaching the value of 2, positive 2. All right, next question. This is the limit of the function as we approach our value in general. There's no direction, no right or left, so it's just a general limit. You don't even really have to look at the graph here. We just have to look at our previous 2 answers. Do our previous 2 answers agree, or do they not agree? In this case, negative 2 and 2 are not the same value, so this does not exist. You can also see by looking with your hands, you can approach from one side, you're going to one value, the other side, a totally different location. Since your fingers are not going together, therefore the limit doesn't exist. Okay, based on this information, we're asking you, is it continuous at A? And if you remember, the criteria for something being continuous based on limits were that the limit as x approached some value a of f of x had to exist. The function evaluated at that value had to exist. And also, the limit as we approach that value of the function has to equal the value of the function at that point. So for several reasons, this fails this continuity test. No, it's not continuous. First of all, the limit doesn't exist, and it has to exist. And second of all, the limit does not equal the value of the function there. What kind of discontinuity is it? Well, the limit from the left and the limit from the right both exist. However, they're not the same value. So that's your basic jump discontinuity. All right, next question. Okay, so we're looking at x equals 0. Here's 0. Here's the value of 0. What's the function doing at 0? There's a point on the graph at negative 2. What's the function doing to the right of 0? So here's 0, the right of 0 as we approach from the right, we're at negative 2. What's the function doing to the left of 0? Negative 2. So now just looking at our previous 2 answers, from the left and the right, it's both negative 2. So the limit as we approach as we approach 0 is negative 2. All right, now checking for continuity. The limit exists, the function exists, and they are equal because they are both negative 2. So yes, it is continuous at A. All right, x equals 2. Here's 2. What's the value of the function at 2? That's way up here. I believe that is 6. From the right, we are approaching the value of negative 2. From the left, we are approaching the value of negative 2. Does the limit exist? Looking at these 2 answers, yes, and it is negative 2. Is it continuous? Well, the limit exists, f of a exists, but they are not equal. So no, it is not continuous. What type of discontinuity? This type where the limit exists and the function exists, but they just aren't the same value, is what we call point discontinuity. It's a removable discontinuity. X equals 5. Here's 5. What is the value of function at 5? Well, there's this asymptote. There's this vertical asymptote, and there are no points. So it does not exist. What is the limit as we approach 5 from the right? Here's 5, here's the right of 5. We are going towards negative infinity. The limit as we approach 5 from the left is going up towards positive infinity. What is the limit as we approach 5 in general? These two do not agree, so it does not exist. Is it continuous at x equals a? No, because clearly the limit doesn't exist, so therefore it can't be continuous there. All right, this type of discontinuity where you're discontinuous because you reach an asymptote and your function's going to infinity or negative infinity is what we call infinite discontinuity.